In this video, I'll be solving the fourth part of first question of UPSC Civil Services Mains 2020 Statistics Paper 1. So for a group of policies, losses follow the following distribution function, that f of x is 1 minus theta by x and theta is less than x less than infinity. So a sample of 20 losses resulted in the following. So for this different intervals, like we got different number of losses. So based on this sample, like we need to obtain the maximum likelihood estimator, Cramér-Rao lower bound using this MLE, and we also have to obtain 95% confidence interval for this theta. So first of all, like if I consider this f of x, so that is 1 minus theta by x, where x is greater than theta. So the corresponding density function for this model will be theta by x square, where x is greater than theta. So therefore, like if for a IID sample, x1, x2 and so on xn, the likelihood, suppose if I am ignoring the constant factors and writing the likelihood, this L of theta is proportional to theta to the power n, product of xi minus square, xi whole to the power minus 2, indicator theta is less than the minimum, because we have like x is greater than theta, so the minimum order statistic should also be greater than theta. So x of 1 is nothing but the minimum of xi here. So for a fixed observed values of xi's, the factor product I is equals to 1 to n xi to the power minus 2. So this does not involve theta. And L of theta is proportional to theta to the power n on this allowed region where theta is less than x1. So therefore L of theta is increasing in theta on this interval minus infinity to x of 1. We can see L of theta is increasing in this interval. So now like if it is increasing, so that means it is maximized by taking theta as the largest possible value, subject to the condition that theta is less than x of 1. So that means the MLE here would be nothing but the first order statistic. So would just be the MLE of this particular distribution model. So with the grouped data, we don't know the exact minimum. So only that like 9 observations, they are satisfying x is less than or equal to 10. So the maximum possible of the sample is the maximum possible value of the sample should be like minimum consistent with this grouped information given. So therefore theta hat MLE would be nothing but 10 in this case. So that like we are considering like based on this grouped data given in our question. So that's the first part, like the MLE of this theta would be 10. Now we also need to find the Cramér-Rao lower bound using this MLE of theta. So first if I consider ln of theta, so that is nothing but ln of f, ln of this density, that is ln theta minus 2 ln x. So dou by dou theta of ln theta is 1 by theta, and the second differentiation of ln theta is minus 1 by theta square. So for one observation, the official information would be minus of dou square by dou theta square ln theta, which is nothing but 1 by theta square. So the likelihood here is, sorry, this is not ln theta, I mean L of theta. L of theta. The same way this is L of theta. So basically dou by dou square of L of theta is 1 by theta square. So for sample of size n, this will just be In of theta, which is nothing but n by theta square. So the Cramér-Rao lower bound for any unbiased estimator of theta is variance of theta hat, which is greater than or equal to 1 by in of theta, which is theta square by n in our case. So the CRLB is theta square by n, and by using this MLE to estimate the bound, so we can plug in this theta hat MLE value, which is 10. So that means the estimated variance after the CRLB plug-in is nothing but 10 square by 20, which is 100 by 20, which is 5. So this is the estimated variance. So the estimated standard error would be, so the estimated standard error, so that would just be root 5, which is approximately 2.236. So that's the second part asked in the question. Now the third part, like we have to find the asymptotic distribution of this maximum likelihood estimator, and we also have to obtain the confidence interval, 95% confidence interval for this theta. So for a large n, like asymptotically, this MLE is approximately normal. So if it is approximately normal, so this theta hat MLE, so we know its variance and we know its mean would be theta and variance is theta square by n. So that means, so we have like theta hat is 10 and the standard error also we have as root 5. So, and critical value for this 95% is 1.96. So therefore 95% confidence interval would be theta hat plus or minus 1.96 standard error. So that is nothing but 10 plus or minus 1.96 into root 5, which is 10 plus or minus 1.96 into 2.236. So which is 10 plus or minus 4.382, which is 5.622, approximately 4.38. So this is a 95%, approx 95% confidence interval for this theta. And these are the variance and estimated standard errors, and this would be our MLE. So that's it for this video. We'll meet in the next video.